So if I gave you that as a question, would you know what it was asking you to do? So the way it's written in the book is to say express 32 root 2 as a single power of 2. It's the long-winded way of saying it, sort of a less exam-based one. Okay. So what we're doing is we're changing the form a bit, like this whole topic has been about. All right. So, any ideas what we could do? Go for it. So, with this question, I'm going to leave the right-hand side alone. So, actually, what we're going to do, so my solution to this, you are going to start with just 32 root 2. And tell me what to do with that. So if I divide it by 32, I'm actually changing it, aren't I, completely? There's no equal sign. So I'm changing its form. I don't want to change its value. Anything? No? Well, what if I said that's the same as 32 multiplied by root 2. So I wouldn't technically write that in my solution, but to help you understand, if I wrote that, would that help you at all? Work avoidance. Mr. Potts making me think about something. Let's try and change the subject. If you want a title, it's carrying on from what we were doing. If you want a title, then we'll do one after we've done this. You can leave a gap. Thought avoidance. I can write. That means I don't have to think. But anything? Any ideas? Pardon? Find it.
You asked, and I.
Yeah, no, I'm just trying to find the square root of 2. Think about what you've been doing, guys. We're not changing topic. This is exactly the same stuff you have the knowledge to do.
Root 2 is the same thing as 2 to the power of 1/2.
Yeah. So 32 multiplied by 2 to the power of 1/2. Good evening. That should give you a clue, because remember 32 was one of those numbers I said you ought to try and remember. So how could I rewrite 32? He's not even ready, but he still said it.
Right.
So you can add because that's how you exponential
Power 5.5. Or 11/2.
Done. What's K?
11/2.
Right. Make sense? Do you want me to do a couple more examples with you? Desks have crept forward. I just can't look at my screen. I don't know why I'm trying to look at that one. I don't need to. All right. So, have you written that down? Happy? Okay.
Oh, wait,
So the next one we'll do one. So that was an example. That was example 4 on page 103. Right. But let's have a look as, again, we're going to write as a single power of 2. Let's do the cube root of 2 divided by 4. Okay. So we're going to write as a single power of 2. Who would like to start me off? Mike?
Could you change 2 to like 2 to the power of 1 over 3?
Yeah, so we've got 2 to the power of 1 over 3.
And over 2 to the power of 2.
Oh.
And then subtract. To negative.
Yeah? Happy with that? Right. Another example then. So going on to the next question. Write as powers of prime numbers. And I'm going to ask you why prime numbers again. So let's look at cube root of 7 multiplied by the 5th root of 7. Nice and easy one to start with.
Would you convert them to, so 7 over 7 to the power of a third, you can multiply it by 7 to the power of a fifth, and then add 1/3 plus 1/5.
Don't know what we're going to do when you move down a group. You're the only one like saying anything at the moment. So
Not good at
third plus a 5th is? Pardon? 8 over. Computer's going slow. Done? Let's give you a different one then. Right as powers of prime numbers. Bless you. Any ideas? This is now combining your surd knowledge and your power knowledge. Yeah? So we've got the cube root of 7 times 2, which can be rewritten as cube root of 7 multiplied by the cube root of 2, which then gets rewritten as product of powers of prime numbers, right? Why are we interested in prime numbers, by the way? Why would they suggest it to prime numbers? What's useful? What do you know about prime numbers? Pardon? So therefore, simplest, isn't it? That's what we're saying. Because prime numbers don't have any other factors, we can't go any further, can we? All right? So that's why prime numbers are quite useful. We know once we've got to our prime numbers. All right? And then it's also quite easy to see whether prime numbers are factors of other numbers. So do you know the best way to decide if a number is prime?
Just test it.
But how? What numbers would you try and divide it by? 2, then 3, then... Because if it doesn't divide by 2, it's not going to divide by 4. So you do 2, 3, 5, 7, 11. Right, so if you want to decide if a prime number is a prime number, you try and divide by all the other prime numbers. Because once I've divided by 2 and I've decided it doesn't divide by 2, what numbers is it not going to divide by? 4 multiples of 2, 4, 6, 8, and so on, right? If it doesn't divide by 3, it's not going to divide by any other multiples of 3, all right? So that's why we use prime numbers for that. That's why they're quite useful, all right? And that's why it's actually quite difficult to figure out whether a large number is prime or not. Okay? And that's why they use them with credit card numbers. All right? So are you happy with those? Any questions on that at all? No? Right, so final lesson on this then. Can you just have a look for me? Practice 4 on page 103. We've just gone through a few. All right. You've got practice 5 on page 105. Okay. And then practice 6, and we have mentioned what to do with practice 6. Can I ask you, please, right, make a little plan for yourself. This is the last lesson we're going to use on this during class time. So, just have a quick look through those 3 exercises. Decide what you're going to do today in class that you might want to ask some help about, right? And then you're going to make a plan and say, right, the rest of it I can do in my own time at home. All right? If you need to. All right? But have a look and decide, try and get through a few of all of them today, now.